This is session 9D presented by Chris Walker from IBM. Time for a checkup. Boost your operational resiliency with proactive performance health analysis. The session is being recorded. You are all currently on mute. If you have a question during the session that you'd like to ask, you can put it into the chat. I will be monitoring. If it's appropriate, I will break in to the session so that Chris can answer it. But at the end of the session, I will be making it possible for you to unmute yourself and ask your own questions. So over to you, Chris.
Okay, thanks, Anna. Good afternoon, good morning, good evening, wherever you may be in the world. My name's Chris Walker. I am a product manager within the IBM Z AI Ops portfolio. Today, I'm going to be talking about performance analysis, operational resiliency, capacity management, looking at the ability to proactively manage the health of your environment and help you understand where there may be areas of improvement within your infrastructure and the solutions that you're running in order to get the best results from your environment. As Anna said, please put questions in the chat, and she can jump in if there is a appropriate point to ask me the question. Okay, so I'm going to start with just a little overview of why operational resilience is such a key topic for many people within the organization and a critical thing for businesses to think about. There are different stakeholders involved in this, and there are different challenges that each of them are covering. And we're going to look at two of them here, which is really the kind of the management CIO level team and also the operations team, the people at the coalface who are actually doing a lot of the work and has the responsibility of understanding from this from a technical point of view. So at a management level, they're looking at obviously the business goals and making sure, wanting to invest in the right areas to make sure that the IT that underpins the business is supporting it and is aligned strategically with it. So that means that they're often thinking about aspects of innovation and developing new product or supporting new goals within the business. However, they also have to balance that against stability. Rapid change, which is not controlled, can lead to poor performance, poor SLA management, dissatisfied customers ultimately, and that costs the business. So if there are poor resiliency within the business, you can see an increase in the number of incidents within there in order to manage the environment. Often they find that a lot of the time the innovation is stifled by not being able to adequately manage what is already there. So a large amount of resource spend is covering just keeping up with what they've already got. And within that might be a result of poor planning. It might be a result of failure to sort of keep up and modernize effectively. It might be a result of environmental changes or bringing in new organizations as part of a merger or an acquisition. So there are lots of complicated reasons why environments have been built up into complex environments, but also we have a problem of siloed teams to manage as well. And that's often maybe just a historical result where we have traditionally maybe a mainframe team is not connected to a distributed team, but now we see workloads that span both environments. And therefore, when there is a problem, there's a lack of cohesion between the two teams, and you end up with these very inefficient war rooms where everyone is trying to prove their innocence in that situation as well. And all of that contributes to the time taken to detect, to isolate, and ultimately resolve problems. Conversely, if we look at it from the perspective of the operations team, they may be struggling with this from a different perspective. They've got alerts coming from different sources. They may have alerts that were based on assumptions and workload patterns that were perhaps true 10, 15 years ago, but are not appropriate for the workload today. They might be using multiple tools to actually look at different systems. So there's maybe something that's looking at SMF data across the environment. They may have something specialist for kicks. That might be different to what the distributed teams are using, which is different from other operations teams. So it becomes a much slower process. There's a lot of friction involved in sharing that data across the teams. And the other aspect, which I think has been obviously well discussed within the mainframe community, is the level of skills within the team as well. There are a lot of people with a lot of deep knowledge that's been built up over decades of experience working with not just certain technologies, but also the unique environment within that organization. So there's a lot of what we might call domain or tribal knowledge found within organizations, and that's often with people who are in their later years of their career. And that is not as easy to transfer to new people who don't have the luxury of spending a couple of years to work out how to do this. So there is a risk around losing talent and losing that domain knowledge within the organization as well. So when we talk with a lot of customers around what are their challenges within this, there are many different ways that we can look at this, and also there are many different personas involved or users that are impacted by this. I'm going to focus on 3 of them here just to sort of show some of the common challenges that we often hear. Firstly, we have a challenge around unpredictable workload patterns, and the key workloads are changing. So this may be a result of, like I mentioned, sort of changes in underlying assumptions on what's happening there. What happens is often that we have to react to the issue. So there may be a symptom such as a slowing application, or perhaps a transaction goes into a loop, or there's a burst of workload that causes a shortage on storage, which we can resolve quickly. But we never get round to looking at what the outlying cause of that is, so that we have to constantly react to this going forward and never fully get ahead of the problem. Another challenge that often comes up is the ability or the requirement to balance capacity performance with the cost within the environment. So this could be where we're trying to make the best use of the investments and resources that we already have there. Periodically, organizations might have a health check. They might have IBM take a look at this environment as well. But if it's been a long time since they're doing this, and workloads are changing, so maybe you've got KICS workloads or IMS workloads that are now front-ended by ZOS Connect, so that they're API enabled, it may change the pattern of that workload of when you're going to see spikes and increases in the amount of transaction throughput that's required there. So maybe things aren't configured right, which is leading to some of the problems that are being seen there. And the third use case I'm going to focus on is around the capacity planning. And I alluded to this on the previous slide, which is there is so much for a new person to learn, both about ZOS generally. A lot of people come in very fresh and don't know a lot of the concepts and have to learn it because it's quite a different environment. But also that understanding capacity planning as a discipline has some very specific attributes related to the mainframe, and also within the organization's environment as well, where to focus on. So when there is a problem, when in terms of either capacity management or planning, there can be difficulty in understanding where to focus or where the potential problem could be. So when you have unaddressed issues in both performance and capacity, that may be a short-term issue that can be resolved quickly, but it actually results in business application problems or perhaps resiliency problems, which ultimately could affect the business efficiency and ultimately customer satisfaction in terms of supporting the actual business goals. So a real aim for most organizations is to move from a reactive to proactive management, and therefore getting ahead of problems and actually not actually have the problems occurring in the first place, but actually have a more efficient environment that can be worked with. What I'm going to be talking about today is a solution from IBM called IBM Z Performance Capacity Analytics. It focuses on performance analysis, capacity management and forecasting, and also cost management there. So all of this ties very neatly together. So we're looking at productivity, performance, changes in behavior as you run through this, to help you understand where there are problems with the environment and where you can make optimizations to improve performance and potentially reduce cost. Ensure you have the capacity to deliver the SLA goals that might be occurring, and whether when that changes, you are able to identify that early, and also for aspects such as cost management. So maybe you have a chargeback or showback policy to consumers within your organization or to other customers, but making sure that you're making best use of the assets under your control. I've got one architecture slide today, and this is the only one that I'm going to go into sort of detail of how the product works. The important thing is getting the data into an area that we can analyze with, and a critical part of that is getting that data both accurately but also in a timely fashion as well. So pulling data from all of your environment across all the LPARs into what we call a continuous collect process will allow you to get the data in a near real-time fashion, so that you can start to analyze that data very quickly. You can build up profiles so that you're not looking at yesterday's data today. If there is a problem that needs to be deep dived in, or you want to look at the results of what's happened in the last hour, last 6 hours, last 12 hours, you can pull that data in there as well. You can also include non-SMF data. So primarily we're looking at things that are coming from ZOS and SMF sources, but IMS is typically not providing data through SMF. You can use IMS logs. There is also sources from even outside the platform. As long as it is a structured format, it can also be loaded in a batch as well. Once that data is into the hub database, it is processed, it is summarized, it is we don't store the raw SMF records here, but we actually have the curated records to show a certain detail on the attributes. So what is the analysis across both timestamp level all the way up to hourly, daily, weekly summarization. And you can control that data and how long you want to store it for and how long you want to read from it as well. We can also apply forecasting algorithms to it as well. So once you've built up a database of source information, we can start to do additional analysis on that in order to start to do forecasting and trending around that, what is being done there. And that data is there and it's highly consumable. So you can either stream it out to a third party such as Splunk, Elastic, or wherever you want to do that. You could write queries to pull it yourself and write your own analysis on there. And if you wanted to use it as a data scientist, it's available to do that. There is also a large set of predefined reporting. Now, the heritage of this product means that we have a lot of green screen 3270 reports that are available there, but we also have reports in more modern interfaces such as Cognos in order to show you details on performance within that as well. Now, many of these components, because it's running on platform, will be able to work within on a zip processor as well. So the overhead of running it is minimized as we run through this. Okay. So with that architecture covered, What I'm going to focus on is some of the key enhancements that we've delivered here, and in particular around the topic that we're talking about today, which is improving the health and efficiency and the resiliency of your environment to do that. And one of the key enhancements that we've been doing is to make even more out of the box use of the data that we're collecting. So you can build up a very detailed profile within the database of what is occurring within your system. We do a lot of curation on there. And what we're building out is a better user experience around how to interpret that and assist you in interpreting that information. And one of those key areas is what we call the health metrics scorecard. And what it does is it applies a set of rules around the key areas of the environment in order to provide a health view of your overall ZOS environment. Now, these rules are not just something that we've made up or made a guess at. These are rules that we have worked closely with IBM's Washington System Center and other key experts in order to understand what they would interpret as the important capabilities and the important thresholds that would be required to identify a healthy system. And we have started with, on the ZOS side, a number of around about 40 rules to be applied there, looking at things such as the Sysplex level, LPAR level, going down into memory, DASD usage, processor information as well. We're expanding that out. We've added support for MQ rules as well to understand the efficiency and understanding of queues and managements in there. And these will be processed on a hourly basis to understand the health of the environment and make sure that there are any changes within there. It will allow you to identify changes in that if something has occurred that is different. Some of these rules are fairly static because they're related closely to the hardware. Some of them will change based on the workload as well. So you'll be able to be alerted to changes in the environment profile within there. You may also use this as a way of doing a health assessment periodically. So you might want to do this over a period of time, or you might want to do it on a continual basis as you run through this. The choice is yours there. So the key functions are taking the SMF data that you're probably already capturing. Certainly if you've been using IZPCA for any period of time, you are probably capturing, well, everyone is capturing the SMF70s. Also the 113s and 245 records are also being used for certain rules. If you are not collecting the right SMF data for the rule that is being assessed, that rule is just skipped as you run through this. You can, as I showed on the previous screen, there is a scorecard that shows all of the details and all of the rules for that period of time and that system that you're looking at. You can filter it on each different system to look at it, how many days back you want to look at, and go back in history to look at certain days that you might have made a change on. You can also filter down on the rule group to look at a certain set as well, and also which particular, if there's something that's being highlighted that is a problem there. The rules are, as I mentioned, have been defined in conjunction with Washington System Center and other subject matter experts. So typically we would not recommend that you change the rules. It is possible you could go in and update them, but the idea is that we have provided that recommendation out of the box. You don't need to make excessive changes on your part to do this. Now, when you look at the rules, you can have a look and it will give you a detail around where it fits within the criteria or the threshold that's in there. If you want to know a little bit more about what is happening, you can click on the little eye icon and it will tell you details on the rules and where the thresholds lie within that. When you look at the summary, you can also see that each rule gives an indication about why the current score has been allocated. Now, what we're looking at here is obviously a mix of different rules. We can see the CPU utilization one at the top there. That's obviously one that changes quite dynamically throughout the day. Some of them are, as I say, very static. That second one about the coupling facility technology levels, that's not going to magically change, because it's more around what are you running with the an up-to-date generation of hardware that is in full support. And I just wanted to run through a few examples of the rules there. And as I say, there's over 40 rules related to ZOS. There is probably around about 20 rules now related to MQ, and we'll be adding more as we drive forward with this. So you can look at things such as on the sysplex level, I mentioned that, the generation of hardware. We can look at things like the ratio of logical to physical engines. Is there enough processors to manage what is being run there? Do you have a lot of parked engines at the higher there, or zips being efficiently used? Other calculations that are being run there within that. So as that, you can go and look at the documentation for the full list. The rules are automatically applied when the data is there to be applied within the environment. So there is not configuration required in order to run those particular rules. Now, let's say that you have a problem that you want to go into more detail around. Let's say that in this example, the system capture ratios is highlighting red because we've seen a change in performance, or there is an issue that is occurring there. You can drill down to go and look at the details of this as it goes through, and it will give you the full history of the data that is within there, and you can start to look at the profile of when we see the problem occurring, and isolate that point in time where there is an issue there. From that point, you can then start to move towards the issue and the more detailed information in some of the other reports in order to try and identify the root cause of why this is occurring. What other workloads are running at that time? What workloads may have been contributing to this, and other problems within the environment. We can tie this together with things such as exception-based reporting, which IZPCA has as well. So this has been something that has been in the product for many years, and it's not so much alerting in the same way that your monitor might be, in terms of, I want to respond to a particular incident and I want to respond to it now. It is more, I look at it as a record of when a certain behavior was observed within the system and where it was observed. So its value is looking at when and where things occur and the volume of the exceptions that occur. So these are static thresholds that in most cases, which identify a particular behavior that's seen. And we look at it in terms of how many times that exception occurred an hour or by a day, and look at that trend across there. So we've got a bit of an exaggerated situation here, which I'm just kind of showing that, we had a fairly static set of exceptions going across many days. And then on one day, we started to see a big jump. And from that, and we can also look at, where that occurred, which systems, which LPARs it ran on, which particular exceptions were triggered. And that will identify that we're seeing in this case, it's not very subtle, but when you might see a more subtle change in performance that you would want to go and investigate. So potentially you're not looking at something that's going to be an immediate response, but you may be wanting to do something that I'm seeing something trending in a direction because I'm starting to see certain exceptional situations occur more frequently or less frequently than previously seen. So when we go and do that investigation, we can drive into reports such as our key performance metrics reports, and also some of the more detailed reports that are in there. The examples I'm showing here are coming with our Cognos reporting, but these are just front ends to the database. There is a lot of data within the environment that you can pull from to do this. Our KPM reports and our KPM tables have been built with the idea that You want to be more in control of the volume of data that you're collecting. Again, these were developed with IBM subject matter experts assisting us in terms of capturing what is the essence that all people would be interested in viewing. So what are the top reports that anyone would want to look at in order to understand the health of an environment? And that can help with both newer people who maybe don't know where to go and start looking for, even experienced people who want to just cut away from some of the noise that might be within the environment. It can also help in terms of the volume of data that you might be collecting. When you start to get to the point where there are SMF records being cut at a much greater frequency than in the past, you want to be able to process them in near real time. You need to be able to also store them. How much DAS do you have available to store this information? You want to avoid just collecting data for the sake of it and processing it for the sake of it. So our KPM reports have been designed to get to the basic information that is required in order to do that reporting and analysis on the system. So when we talk with new adopters of IZPCA, we often say, let's start with the KPM reports, get that information running and understand that. Now, there may be other data that you're interested in that you'd want to be able to look at as well, in which case you then start to add the collection of that SMF record or add to the volume of data that's being collected, because that's specific to you that you know that's important. But these key reports are designed for making sure that what everyone wants to be able to see within the environment. And you can start with a high level view here, which is showing you the all of the key information, and then from there you can drill down into more details around each of the different attributes within there. Now, what another aspect that we also want to look at is what's the future trending within here as well. So we can apply forecasting when we have a good base of data to look at. And within here, you can use the forecasting capabilities to provide a trend on there in order to see where are we heading towards. When you use forecasting, there are many different algorithms that you could apply in order to drive this, and that can depend on the nature of the data that you're looking at. So you can choose between what algorithm to apply within there. We have for something like perhaps storage or storage usage or disk usage, something like a linear approach might be most appropriate. When you start to get to CPU utilization, some kind of polynomial with represents the more complex pattern or Fourier type algorithm within there. We also have capabilities what we refer to as a fractal approach, and that can be used for grouping certain unique events together. So if we think of things that you might want to group together because they represent a certain profile for your business. Think of things like Black Friday or the Lunar New Year or some other holidays. They're not typical of your normal Thursday, Friday behavior within a month. They are special, and you'd like to be able to group those particular days together in order to get a profile of those particular future events that may reflect that profile as well. So we can also apply that. The next algorithm I'm going to just talk about is what we call our smart path profiling. And we apply this on a couple of reports in order to build up a special profile of, in this case, CPU utilization over the entire week. And we do that on an hour-by-hour basis. And it allows us to understand what is the expected behavior for that hour across the week. So obviously 2 a.m. on a Sunday is very different to 9 a.m. on a Monday. So, and even 9 a.m. on a Sunday. So we want to be able to have that unique view across the week, and we want to be able to set a what we refer to as a smart path, like a window of toleration around where we expect the actual performance to be. And as we measure this actual performance across the week, we will see if we are tracking with the baselines that we are working with. So here's an example of a business analysis application profile view that we have built up here. You can see a set of line charts that run across there that are showing the expected MIPS consumption of a particular application across that week, across multiple weeks, but it's the calculations are done on an hourly basis, and we're showing several weeks worth of data here. In fact, several months worth of data, because it's quite a long range that we're showing. Now, what those line charts represent, obviously we have the yellow one, which is the median, where we would probably expect the workload to run at. We have then a upper and lower bound that we want to work with, which can be set in terms of number of standard deviations from that median that we can show. And then the blue area is actually a bar chart that is showing the actual observed MIPS usage for that hour across the weeks and months that we're showing here. And as we track towards that, we can see where we are either above or below, and it's quite a mix of data that we can see there, and we can tie those back to those exceptions that I was talking about. So if we spring out of the smart path area, then we can be told about the occurrence of this and register that we're seeing unusual behavior or unexpected behavior as we go through this. This is a threshold that's obviously more dynamic than just setting MIPS usage manually across the week. So this has been built up with what we would call a dynamic threshold, and that is being built up through the historical data that we get. And obviously, the more data that you can collect, the better. At least a month's worth of data is useful, probably get up to 3 months before you start, when you start to see real value across this, because you're starting, the more data that you have, the better the training that you would see there. We also apply a tolerance value to that, which allows you to sort of set up the width of the path that is being profiled. That then creates that dynamic threshold for every hour across the week. And then as the data is coming in and being processed on an hourly basis, we're evaluating it and deciding whether we fall within the area or not. And if we do not, then we get an exception. So here's an example of where that might be occurring as well. So here's a simpler version of this. Again, we've got the hourly profile across there as the up, and we're just showing the upper boundary here, which is the green line. And obviously where I've highlighted with the red circle, the blue bars are the actual observed parts. And so whenever we have triggered up or broken through that upper boundary, we will register a exception within our system to show that. Just want to take a couple of minutes to talk about some other recent updates that we've applied to the product. So you may not have seen these yet if you're an existing IZPCA user. Firstly, we've expanded our KPM reports to cover more MQ details. This is based off, obviously, the 115 and 116 records. The 16 records are now being recommended in some parts by IBM to be collected all the time. They're highly voluminous to show the traffic through MQ. But we have built reports that if you have those switched on, you can also show that as well. We have also, in the last couple of weeks, refreshed our Linux on IBM Z reports. So one of the key things to think about when with IZPCA is that it is not just a ZOS reporting tool. While it does store its data on DB2 for ZOS, you can pull in data from multiple sources as long as that data is structured. And we actually have reports for some distributed platforms like Windows. We also have some stuff on Power as well. But critically, there are more and more people who have IFLs, maybe even a Linux one box somewhere. You can pull that data into IZPCA as well. And we have built up a new set of reports for customers who are using Linux on Zeddas. So looking at both performance overview, how much CPU is being consumed over time, disk I/O, the sort of key metrics that would be important for Linux users to understand where that basis is there. We're also adding more support for I guess some of the other SMF records that are out there, because we're seeing more and more usage across some of our customer base. So a lot of network updates are now wanting to be tracked. So we've been adding support for a lot of the subtypes on the SMF 119 records as well. We'll continue to do that. We've also updated support for some of the IDAA performance statistics as well. So you can actually use IDA in conjunction with IZPCA in order to maybe offload some of the data from DB2 on ZOS. But also we're seeing more and more uptake in terms of the adoption of IDAA as well, and people wanting to report on the performance and the throughput of data that's being processed and queries that are being run on IDAA as well. Okay. So the last main topic I'm going to touch on is around resource consumption. And this is becoming, or has been for many years, an important topic. But in the last few years, there's been quite a change in how a lot of people have been looking at their resource and consumption on the platform. So for a long time, the subcapacity model has been around the rolling 4-hour average, and that's very important to be managing because it sets your bill to IBM for your MLC software every month, and other software as well. We are seeing a lot more customers adopt tailored fit pricing for software, which does change the dynamic of how you want to manage your workloads and how you want to or have an understanding of what is important that's running on your system. We can help you there by providing visibility into the resources that are being controlled, making sure help you identify where there might be inefficiencies in that environment and help you optimize performance and capacity and make sure that you're getting the most out of the workload that you're running. So we've had this for a few years, but we're able to show you quite a lot of detail around tailored fit pricing for software consumption. So what you would define within with your TFP contract is an entitlement around the number of MSUs that you will be expected to use over the next 1, 2, 3 years. And it's important to understand how it's being consumed, who is consuming it. Are you tracking towards where you expect to be in terms of consumption? Is there a change in consumption? Because all of this will ultimately impact the cost of running workloads on the platform. And as you follow that through, you can obviously look at the SCRT reports every month, but it can often be difficult to identify who or what is actually the consumer of those MSUs each month. So we provide that visibility within there in order to allow you to understand the overall consumption as it moves through. Now, as well as looking at just the top level MSU consumption, you can start to then drill down to understand who is using this, which particular systems is the MSUs being consumed on, which workloads are being consuming it, and help you filter out that information. So we may be finding that a particular workload has been consistently consuming the same amount, but now in the last day or two, it's starting to consume more. This will allow us to get ahead of potentially any problems within there. And similar to what I showed earlier, we can then apply forecasting as well. And actually, forecasting is one of the more interesting areas for TFP management, because yes, you have a set of MSUs that you would want to consume over the lifetime of your TFP contract. However, that doesn't mean to say that going over the amount of MSUs is necessarily a bad thing. If your workload and your business is growing, well, if your business is growing, you would expect the workload to run on your system to also increase. So therefore, you know, if business is good, then yes, sometimes costs will also increase as well. And it's good to understand where that balance is between the cost and the growth within there. So having an accurate view of your MSU consumption, what I'm showing on this one is a very simple flow of the forecast in the purple, and we can see that horizontal line where it crosses just towards the end. Well, that's saying that actually before the end of the contract, we will go into growth MSUs. And growth MSUs means that, yes, there will be new MSUs that will be billed at a competitive price to IBM because of the increased workload on the platform. Well, if again, as I say, if the business is good, then this will be a payoff, and we can understand quantify the additional cost to the benefit of the business there. Now, if it's not, business is not growing, and actually all we've got is growing workload and ultimately leading to growing costs as well, the forecasting can help us here because we can understand that we are trending above where we want to be. We can understand who is using that, and we can understand potentially why it's increasing over week over week, month over month. But we have visibility and time to make that informed decision to then make changes in order to bring that forecasting line on the actual line back in line with where we want to be by the end of the year. Similarly, we have support for the TFP for hardware view as well. This is an optional extra for TFP customers who, if you want to purchase an additional reserved area of hardware capacity that your workloads can spike into without having to get permission, like on a capacity on demand model. Think of it as a kind of a reserved space within there that can be used and activated immediately. We can track that as well, and we'll show you where the area of capacity is, how close you are getting towards it, and if you spike into it as well. So we'll tell you if you have spiked, and additionally, so what would be the cost that's involved in spiking into there. Again, TFP for hardware in that reserved area going into is not in itself a problem. It's probably what you'd want to do. You have that reserved area because if you have an increasingly spiky workload, you can use it without having to jump through hoops to get that additional capacity enabled. What you want to be able to track, though, is when does it happen? How often does it happen? And again, the trend around when that's actually occurring. So spiking into it, and I'm just going to say, for example, once or twice, that's perfect. You're using TFP for hardware for exactly what it's occurring. If, though, it starts to become 4, 5, 6, 10 times every day occurrence, then you're starting to see a change in the workload, a growth in the workload, and probably a sign that your actual purchase capacity is not adequate for the workloads that you're seeing. Now, obviously, you might be able to bring down the consumption level, but if you're also growing as well, you might use this as a sign to justify additional purchase capacity to increase the amount of capacity that's there, so you don't spring into the additional space. And again, this is links back to what we can do with exception reporting. So we can put in an exception to say, how many times did we spike into the hardware corridor for TFP? And look at that trend as well. So the analysis that IZPCA can do here can show you where trends occur within that time frame. So closing off the sort of the TFP aspect here, and we do support reporting on the rolling 4-hour average, but I wanted to kind of talk a little bit more about the TFP aspect because it changes the way around thinking of capacity management. With the rolling 4-hour average, you effectively architect to manage cost. You know when the peak period is likely to be because you probably have a peak period each month where there's a lot of processing or there's a high volume of transactions that need to be managed at that point, and you make sure that non-essential workload is kept out of that period in order to avoid making that high watermark any higher. With TFP, because you have an MSU as an MSU, it doesn't matter if it runs at 5 p.m. on a Friday or 2 a.m. on a Sunday, it effectively costs the same. So you change the way that you are looking at consumption within the environment. And that's why it's important to understand, who is consuming MSUs and what are they doing. So once you have that understanding of your MSU consumption levels, it can lead you into discussions around optimization and thoughts around where we can make strategic decisions in order to improve your efficiency within the environment, reduce costs, and make sure that you have a more resilient environment. So it might be something around application optimization. It could be looking at workloads that may have been running for a long time. They run certainly outside of the rolling 4-hour peak period, but ultimately don't contribute to the business as much as you thought it would. So you can actually maybe even decommission some applications or change how often they run. That could also be true for subsystem optimizations. Maybe you're running a database reorg quite regularly, or maybe you haven't run one for a long time. If you can look at optimizing how Kix IMS DB2 is running, then that can also potentially bring down the number of MSUs that are being consumed each week in your environment. We may also look at the use of compilers or other updates in order to improve application performance. Maybe you have some applications running that were compiled with a COBOL compiler, let's say 10, 15 years ago. If you recompile that with the latest compilers, that could bring down the number of MSUs that that application is running. Or use something like the binary optimizer for certain workloads that are not being actively developed at this point in order to improve performance. There's a lot of options there, but it all comes back to understanding the who and the what of how that applications are running. So as we close this off, let's think about our 3 initial personas or use cases that we were talking about at the start. So with a better view of the environment, we can understand where systems have been constrained and where we've had these outlying problems that ultimately lead to application issues that impact the problem. Using something like the health metric scorecard, we could see that at certain points in time, we actually had insufficient engines for that workload. And we made changes to adjust this. That might be moving workloads around. It might be getting more engines into the environment, but understanding that was the root cause and where that pinch point occurred was critically highlighted by the health assessment. We can also use the health check to pinpoint issues around creeping CPU delays. We could look and find out which workloads were impacted and make changes so that we make better use of the resources. Again, it might be just moving certain non-strategic workloads or non-time critical workloads to a different point in time in order to make better use of the resources and allow the more spikier or volatile workloads more capacity because we don't know exactly how much they'll use at each point in time. And thirdly, for our less experienced users, they can use things like the scorecard in order to isolate where a particular problem is. When you're faced with an issue and you don't know where to start, the scorecard can highlight where potential problems could be. It could say there's an issue with DASD response times within the environment, and we can eliminate a lot of investigation paths that would not be fruitful as we go through this. So our recommendation is if you are an IZPCA user, to start using the scorecards today, or and look at it on a regular basis to understand how your environment is performing. Understand where there may be issues potentially that could grow into actual incidents that impact end users in the medium to long term, and then that will help you set a plan on how to improve on that. One of the last topics I wanted to just touch on, because we've just recently released a blog article around this, and I think it's a very important one for people to think about and understand, is I mentioned it earlier that yes, we have a lot of out-of-the-box dashboards and a lot of predefined reports that can help you get immediate insight into problems within the environment. But this data is very valuable, and it can be used in many different ways. And you may have data scientists, you may have performance analysts, you may have capacity management people who've got their own tool or would like to just play with the data and do something with it. And I'm just sort of showing you here different examples of us pulling that data from the IZPCA database and just throwing it up into other tools that you might have available to you. So the top example is CPU LPAR usage by KEC in Grafana, and this was just queried out of the database, and then if you have someone who's an expert in Grafana, they can then sort of present that data there. Similarly, something like Power BI that's all IZPCA data there, or Splunk. You might have someone who wants to just extract the data and run some Python scripts to derive further insight into that. When you get the slides, you can go and read the blog, and it gives you some guidance on how you can do this. But yeah, the data is there, and the data can be used however you want to go with it. So in final summary, I spoke a lot about the health metric scorecard, but it's really just one of the features that we have within IZPCA to help performance analysts, planners, IT management. We have lots of capabilities within the different verticals that we support. So our KPM reports help us lower the amount of data that needs to be collected and give you the right information within there. The exceptions can identify trends within there and help you get to looking at the right problems. And we can also use that smart path profiling to give you better insights from usage, both from right at the top level, from the machine level down to job levels within there. Our capacity forecasting capabilities are continuing to be built out. I showed the forecasting capabilities today. There's some other areas that I didn't cover today, such as our what-if analysis within environment changes. So if you wanted to move to you're planning your move to a new machine, we were able to do some modeling there. We can also apply things like growth factors so that you can see what the impact to a batch workload or real online workload would be if you were to grow that workload by a certain percentage. And I touched also on some of the cost management capabilities, such as the tailored fit pricing part. I didn't really cover it today, but we can also provide resource accounting for chargeback and showback capabilities. So if you're doing internal billing to consumers or departments within your environment as well. Finally, if you are not an IZPCA customer and would like to give it a try, we can offer you a rapid proof of concept approach. This would be that we would discuss a particular scenario that you would be interested in. You would provide us with some SMF data that we would load into an environment within IBM, and we would generate the reports. So you'll see your actual data in the reports, and we will discuss that with you. You can take a look at it, so you get a full view of what you would experience with IZPCA with your data within there. If you're interested in any of that, you can reach out to me or talk to your IBM representative, and we'll get it going. Finally, last slide, and you'll get, when you get the slides, there's a lot more information in here that you can go and find out more about IZPCA and the IBM Z AIOps community. And with that, that's the end of my presentation today. I appreciate your time joining us. If you could give feedback, that would be very much appreciated. This is session 9D, and if there are any questions, I'll take them now in the last 5 minutes or so. Otherwise, thank you very much and have a great afternoon.
Thank you, Chris. I have given everybody the ability to unmute themselves if they like to pass comment or ask any questions. Not seeing anybody unmute. Giving it a couple of seconds because sometimes it's hard to find how to. Okay, it would seem we have no questions. As I said, thank you. Everybody, if you can please give feedback. We do use that information when we're planning other conferences. So what worked, what didn't work. And thank you for joining.